There we go. All right, we are now live, gangers. Gang stars.
Oh yeah.
All right, first problem of the day is find gradient fields of the functions. So which one should we do? Should we do the first one or the second one?
We should probably do the second one.
Number
Alright.
2 looks interesting.
Yeah. All right, and another thing. So I feel like most likely on this test, he's gonna have us have the ability to have a what is it called?
Note card.
Note card.
Note card again for formulas. So anytime there's a question that has like a formula that you use, we should note that and have it ready. Because at the end we could do like a quick note card rundown, or we could just send a picture of the best note card.
Has he said, like, confirmed about the note card or no?
I don't know if he's confirmed
No,
it.
but the last two.
Yeah, but
Yeah,
also
the last two has.
yeah. So we can also, since
The
it is
second to
the
last
19th,
one.
we can ask.
Yeah. Well. Yeah. I'll probably ask one on Tuesday.
Yeah.
But
I'll be
one
there for
thing
that.
to remember is that last test we really didn't need a note card, and he gave us one anyway. So in this test we have a lot more formulas. So
Dude, I forgot to like scan the note card last test, and it's like, well, I don't think I used it anyway. So
Oof, risky gang. All right. So let's see.
yeah. Okay. So we're doing number 2, and we're trying to
We're
find
gonna
the
do number
gradient.
2. Find the gradient fields of the function. All right. You guys can see my screen proper, right? Like the exercise thing?
Yes.
Oh, wait. Why'd we start here? That was kind of cringe. I started us on the wrong one. Yeah, let's just finish it.
5-2.
Yeah, let's just finish.
Yeah, let's just finish 5-2.
I started on the wrong one.
That's okay. I got an answer.
What would you say your answer is?
I got x over x squared plus y squared plus z squared, I plus y over x squared plus y squared plus z squared, and then z over x squared plus y squared plus z squared.
Okay, so in this, it
We
sounds
did
like
number
there's a...
2.
Yeah. I just realized that too. We did an even when we only have odd solutions. But that sounds like it's a similar process for 1 as well. So from the answer you said, it sounds like, what is it, using a formula where it's like a gradient breakdown, where it's, partial with respect to x.
partial
plus...
xi, partial yj, partial zk.
Yeah. So the gradient field produces an ijk output.
Yes.
Yeah. So
Yeah.
then.
Well, this is just the gradient. Wait, gradient field.
Yeah, this is gradient field.
That's
right?
the gradient. What's the gradient?
Well, I can look at the solution set for number 1, since we don't have the solution to number 2, and we can see what the format of the answer should be. It looks like Oh, that should be over here. 2. So this is what number 1 is. It looks like it's in the form of an ijk times. So yeah, it looks in a similar manner for the first one. You have partial, but it's missing its numerical coefficient. It has its sign change to it. Well, I actually have to look at this to start. Oh, that's all because of this. So it's because we're using the chain rule. Yeah, so. Okay, so the formula for these questions looks like it shakes out like so. What you guys said earlier, like your partial, is it partial ix or partial xi?
The I coefficient is
Oh,
the
yeah,
partial
it's separate.
derivative of in terms of x.
So this is df dx? No. If we were to write this out notation wise as like a formula, this would be partial fd. I feel like we used this in the homework. Well, we definitely did.
So the gradient vector field is what we had, where it's I, j.
Yeah, jz.
It looks like they just factored out
Yeah.
in the number 1.
So what this goes. So you got x over, x squared plus y squared plus z squared.
That's
I
for the I, and then
plus y over x squared plus y squared plus z squared for j.
yeah.
And then plus z over x squared plus y squared plus z squared for k.
Yes.
So the formula
Because
for that.
the first two,
Yeah. Oh,
the first two chain rules are the
yeah.
same for each one, and then the only thing that matters is at the end what you derive the inside function for.
Yeah. So the thing that's interesting here is looking at this. If you were to just take, let's say, if this was just, oh, it's because of the square root, isn't it? That's why the 2 goes away, right? Yeah,
Well, no, it's x squared, so the derivative of x squared is 2x. So the 2 goes away that way.
So but then, but the 2 isn't on our I, j, or k for any of them, right?
Oh yeah, that too. So it's the 1/2 that is derived from the derivation of
chain
the
rule.
square root. Yep.
Yeah, so that's what I was trying to say there, that because the square root's here, because I was wondering for a moment why the coefficient goes away, the integer coefficient goes away, and that would be why. Because, so that's why, so we're writing it out a different way than he tends to have us write it out, it seems, or at least they do. Because this is how we should have written it, right? It should have been x, y, z, so like xi, yj, zk, times, our denominator, like the negative first power.
Yeah.
And then on the front, there would have been a 1/2. Well, no, there wouldn't.
There would be
no, we wouldn't have
1/2.
to. Yeah, we wouldn't have to. We would only need the 1/2 if we kept the 2 on the x, y, and z, which we didn't. So that's how it would look. So this one's pretty formulaic for the most part. It's just derivative tests, right? You got to know how you do your derivative of, ln root of, inside. But
u prime over u, and then the derivative of something squared is the derivative of the inside squared over that squared.
Yeah, we went a little far ahead though, since we started early, and we also chose to do an even. So next time, let's take that in consideration as well. So let's go back and start where we're supposed to start. over here.
Yep.
So line integral time over space curves. So this time it looks like he's kept his word on that and done odds only. So we have to evaluate xy plus y plus z ds along the curve r of t is equal to 2ti plus tj plus 2 minus 2tk bound 0
Wait,
to t to 1.
are we doing 11?
Yeah, 11. We'll do 11.
Okay.
So that's xy plus y plus z along the curve r of t is equal to 2ti plus tj plus 2 minus 2tk with boundaries given.
Okay. So
All right, well, let's go through. Well, first we can
I got
confirm your answer. Yeah.
2/3 plus 3/2. That is 4, 6 plus 9, 6. 13, 6.
13 halves, so somewhere there's a 3 in the numerator that needs to go. It's 13 halves, supposedly, is the answer here. So
Are
looking at this,
you the-
well, this is our solution. It might, I mean, there's a chance these are wrong, but let's operate under the assumption that they're right until proven otherwise for now. So let's go along. So Jeffrey, do you have an answer for yours that's 13 halves, or do you have a different answer?
I got 35 over 6 for 11.
Okay. Let's go through how we do this. So to start, so it gives us the curve, right? Already R. So do we start this by setting each of these components to like X, Y, Z, and then taking the derivative of them? Or is that
So
a
I
different
kind of
version?
plugged the IJK components in as the XYZ, and I
Yeah.
believe, that's you get like your IJK there, and then you dot product with the derivative of that. So I got 2t squared
Oh,
I
okay. So what it's
plus tj minus 2k dot
So
2I plus j minus 2k.
all right. So let's we're gonna explain it hopefully so anyone who watches this could understand right go. So to start, we're given two things, two pieces of information. We're given an integral with respect to an xyz function, and then we are given a function rt or a curve rt, which is in respect with respect to t across all of its components. And then we're given this portion of t. Obviously, when you're given this, this ends up being your bounds of integration, correct? This right here at the end.
Yeah.
So then what we do to start is, as you said, you plugged stuff in for x or whatever. So this component 2t goes in for x in this function.
That's what I did.
And then obviously t for y in this function. And then 2 minus 2t for z in this function. But did you turn this into this is an I, this is a j, this is a k? Or did you just simplify this out?
I turned out IJK and actually
Okay.
I messed up because I put in -2
Okay.
instead of 2 minus 2t.
So you went about, so your first portion, so you turned the integrals function into 2t squared I plus tj. Well, this is just, and then the last one's just z, so then it's just 2 minus 2t k for that. And then you said you dot product, or you did the dot product of the curve function and the synthesized function. So you took the dot product of 2t I plus t j plus 2 minus 2t k. You did that, you went up.
I got the wrong answer twice. So
Boy. All right, let's see. All right. All right, Jeffrey, next step after you did your dot product, did you get 4t cubed plus 5t squared minus 4t plus 4 for your dot product?
No,
What'd you get for yours?
I got 4t squared plus 5t
Squared.
minus 4.
So
that's what I got.
so when we do the synthesize,
Because you're taking the derivative.
when
You're
did you
taking the derivative
when did you take the derivative
of the
there?
of the
The
of the
synthesized one?
R.
Oh. So
Okay, so the formula is
so we're doing the synthesized function times the derivative of our curve, or dot
Yeah.
product with the derivative of the curve. Yeah, so
Yeah.
that would reduce everything by a power, and then the last one wouldn't be the same. It wouldn't
so
be
that's
the
yeah, that's the formula. So we need to get f in terms of t, and we do that by solving our curve, setting each of those points into
All right, so
a
you did.
t.
Yes, you got 4t squared plus t, well, minus or plus in this instance,
Minus 4
plus.
plus 4t.
Yeah, I'm just going to do plus 4t, then minus 4. And then did you reduce that together? Combine it all to 4t squared plus 5t minus 4.
Mhm.
All right.
Yep.
So then from
Yep.
here, what's our next step then?
Then take
Solve the integral.
So we just integrate from 0 to 1 then?
from 0 to 1.
Yep.
All right.
Yep.
dt.
And I got -1/6.
I'm going to try this again and hopefully I get 13 halves or something. But although I doubt it, considering, let's see. We got 4/3 t cubed.
Probably a step we're missing. So I'm gonna go look at the old homework and then see what that will give us.
3 plus 5 over 2 minus 4. Yeah, that's definitely good. This mine just spits out a negative, which probably negative 1/6 as well. So let's see.
Because -4 is a lot bigger than.
Yeah.
Well, I wouldn't say a lot bigger because it's 1/6 bigger, but
Yep, that is in fact negative 1/6. So yeah, we're working. So there's some misconception somewhere. So let's see. So I have on my other monitor, I have a version of one of these problems pulled up to look at. So let's see.
line function formula, and it was like, oh well, here is the function of a line. Here's the y equals mx plus b, and I'm like, no, that's not what I need.
Probably line integral functions the best Google if we had to Google a result or attempt to find it.
Yeah, let's see
So what is this double
what we got.
covariance doing? So from what I'm seeing, the line integral function is, you know, from a to b of function of h of x, g of x, h of t, g of t, times the magnitude of r of t dt overall, where h of t and g of t is, h of t is the function, well, h of t is the coefficient on I in the original R, g of t is the coefficient of j, and obviously this can be extended to 3 dimensions. So then k, of course, would factor in there. So it's the magnitude of that. So let's see if that changes things. F of h of t and g of t.
Oh wait.
So we're looking at x, y plus z. Okay. Okay.
I figured it out.
What is it?
Figured it out. So it's not the dot product, it's multiplying by the magnitude of v.
Of r? Of r of t?
V is the derivative of r.
Okay. So you take
So
the derivative
it's
of
the
r.
derivative. Yeah,
Which
it's
we
the
did.
derivative of f in terms of t, and then multiplied by the magnitude of the derivative. And the magnitude of the derivative in this case is 3. And that's why I was 13/6 instead of 13/2.
I told you there was a 3
Because
somewhere in the numerator in the beginning, but we all just didn't. We're all being cringe. All right, so now the new work function here is, instead of the dot product, our synthesized function remains the same, to where it is going to end up being what is 2t squared plus t plus 2 minus 2t. So in this case, our synthesized function is no longer left in vector terms. It's just combined immediately and then multiplied by a magnitude and then integrated. Or do we leave it in vector terms? Because if we're not doing the dot product, leaving it in IJK form won't help.
Okay, so technically what we do is we substitute the parameterization of the function.
Yep.
So what we do is we parameterize the line. I can barely say that. So, and we take out it from vector form. Vector form makes it very easy to get the parameterization form because you have x in term, your I coefficient is
It's
x,
just x in terms of
your
t.
j coefficient is y, and then
Mm.
your k coefficient is z. So you just plug that in. You don't leave it in I, j, k.
Yeah,
So it's just
so
the coefficients.
so instead of what we did previous with the dot product, we will get 2t squared plus or minus t plus 2 times the magnitude of the derivative, which, as you said, is magnitude of v. So in this case,
Yes,
we
which is
don't use v anymore except for the derivative portion of it,
correct.
which happens to be 3, and then we take the integral of the whole thing from 0 to 1. So multiply that across, you get 6t squared plus 3t plus 6. Integrate from 0 to 1 of that, and you will get 3t squared. No, 2t squared plus 3 halves t plus 6t, all from 0 to 1. And you will have 3 plus 3 halves plus 6. Let's see. That can't be right. I think I goofed somewhere. Where did I goof? Ah, in the middle. It's minus.
So I look. Yeah. Okay.
It's minus 3 halves. This is looking. What did I goof on there?
So I'm gonna leave. So what I did is I left out the 3, and then so for the integral, I got 2/3 t cubed minus 1/2 t squared plus 2t from 0 to 1
Mm-hmm.
times
That's what mine should
times
be,
3.
technically.
So then I did 2/3 minus 1/2 plus 2. So the 2 and the 1/2 become 3 halves, and all that becomes 13/6. And then I multiply it by 3, and that gives me 13 halves.
I'll do it that way. I feel like I have a simple algebra error somewhere. So instead of
Yeah,
carrying the
that's
3,
why I normally leave the 3 out front, because
so
I
we'll
like
get-
to just screw everything up with bigger numbers. I'm literally just like, yeah, it's fine. We're just gonna screw everything up.
do it this way instead. And we will get. Oh, that's a problem.
What's up?
It's plus 2 there. Times 3. And yep, there it is. Algebra error. Don't know where it was, but now I'm getting 13 halves. So this one is a formula one. So let's get down the proper method of it. So the proper formula is the integral of c with respect to f.
Yep. I will make an equation sheet and post it in the group me.
So
And so
the integral of c with respect to f, and how should we define the f? Just f of t?
okay, so yeah, sort of, yes. I
'Cause
will
mean,
write out the long way.
because we have an f, like our function f that's given to us in these problems where like we have to evaluate that along a curve. The curve is where we pull, as you said, our parameterizations from to synthesize a new equation in terms of t using our original one. So if I was to write this, I mean, obviously it has 3 dimensions, so there's probably a better way to denote it, but I would probably just write it as, since we no longer leave it in vector format and we combine it, I would probably just say f of t times, magnitude of v, and define magnitude of v as the derivative of r. But now if we look though, you can see that like 13 and 14, or particularly 13, which he starred, is find the line integral of, you know, f of x, y, z is equal to a very simple function x plus y plus z over the straight line segment from there. So in that instance, how would we parameterize that? Would we find the line segment's equation and then do it, or what's our point there? Because I know finding bounds for this is probably not impossible. You're just given 2 points. You just have an
Okay.
upper and a lower.
So how we parameterize that is we just have to do it by hand. And so we do that by assuming that our t is going to be from 0 to 1. That's what I do at least. And then, so we say that
Do you get to
y,
assume it's from 0 to 1 because that's just what the x components on these points are? Or do you just do that arbitrarily just because?
I do it because it makes things simple.
Okay.
It can be any point.
Yeah,
It
that's what I
can
was-
go from 0. You can go from 0 to 3 if you want to do it that way, but then you'll have like 1/3.
All right, gotcha.
So basically what you do is you just subtract the make the difference of the two, and then that's your slope, and then whatever your intercept is, whatever your starting point's at, that's your plus a constant. Does that make sense?
So you use those points to find the equation of the line?
No, you do that for each point, and that's the parameterization of that point.
Oh,
So what we're gonna do is we're gonna
so
look
you
for
did.
x, and then we're gonna subtract x from
So you
the first
found.
x minus the second x.
So you found so you did 1, or yeah, it's 2 minus 1. So you did 0 minus 1. That's the slope of one line. Then you did -1 minus
Yeah.
2. That's the slope of another line. And then each of those slopes of a line gives you your, you know, in terms of t, your parameter for x, y, and
Yes.
z.
Now I do it that way because I say that t is from 0 to 1.
Yeah.
If you want to do it other ways, you can. You just have to take that into consideration, and you have to make sure that you have a function that gets from your starting point at 0 and then to the end point, whatever that your t is equal to.
Yeah, so good at demonstration of
So
that
you
right
can-
here is this. They both get to the same
You-
endpoint, but they use different paths. This is what you just did. This one.
Yeah.
Component wise. This is obviously definitely the simplest, but if required, you'll have to be able to understand how to do this one. So have a more complex singular C1 path and then a simple C2 path. You could do a direct, but a direct would obviously just be this in terms of vectors. It's just what it is. Right. So there's that. So we have, as you said, you'll just have your formula sheet for anyone watching where they can learn the proper formula for these. The formula carries through across the board. It seems like the only difficulty between problems is going to be if you have to parameterize yourself. That seems like the only complexity, because problems like this where you're given your RFT with parameters, it's literally, as we said, you just pull them and plug and chug for these types, which he has starred. So I would focus on that and realize that there's a chance that these show up. And I'd probably guarantee that this would show up, even though he didn't circle it. But something like this would definitely be a possibility. Let's see. So the next ones we have integrating over curves, we have plane curves, and we have masses and movements, but masses and movements are not showing up. So it looks like it's this or this. So we can probably just do this one just because it's the only one he circled. And then we can decide if we want to do one of these or move on. So we can look at 27 then. So that's what we'll hit up next. So 27, integrate f over a curve. So given some x, y function, it's a relatively simple function. Your curve is y is equal to x squared over 2, with your bounds being 0 to 2. Yes. Okay. That's funny. 28 has the same curve. Either way.
So which one are we doing?
27. And it looks like in 15.1, it's just this one, and then we can pick one of these and we're done with this portion.
Sounds good. So 27.
Yeah, 27.
Oh man. Is this an ugly answer?
Yes. Very.
Okay. Because I just got a really ugly answer for this one.
question is how ugly.
Like, you know, 7. Never mind. Let's simplify this.
Write it in terms of radical. Never forget, them's the rules.
What's 17 times 3? Okay. I got an answer.
What'd you get?
I got 51 square root of 17 minus 3 all over 8.
I got
That sounds horribly wrong.
I got 20 root 10 minus 2 over 3. And the answer is, is 10 root 5 minus 2 over 3.
Lost on that.
Jeffrey, did you get that answer?
No.
Yeah, okay.
So 10 root 5 minus all over 3. That's the answer.
10 root 5 minus 2 all over 3 is the textbook answer. So how did you
Okay.
parameterize? Did you set x equal to t and then y is equal to t squared over 2?
Yep.
Okay.
And then
clear on
the
that.
bounds turn into 0 to 2.
0 to 2 instead of 0 to 3.
Wait, is it 0 to 3?
If you eyeball it, fuck.
That's 0 to 2.
It says 0 to 2. Okay.
0 to yeah, 0 is less than 2. X less than
Yeah. Okay.
2.
Okay.
So what you would do
0 to 2.
would put x in as t, and then x is
Yeah,
equal
sorry.
to t.
I boomed
So
there.
that's what
Wait.
I think.
Wait. I used 0 to 3 by accident. I think because my answer is 20 root 10 minus 2 over 3. So I might be right. I might have just used the wrong number at the end. But either way, so let's talk through it for the people at home. So we all chose to parameterize x is equal to t, and then y is equal to t squared over 2. The reasoning behind why we chose to do that is because the given curve was y is equal to x squared over 2. So it's easiest to parameterize this by setting x equal to t, so your y is simply a function of t. Easy peasy. So that's how you parameterize the given curve problems. Therefore, when you do that, and since x is equal to t, and so this is something, adjusting your limits is important because we got lucky here, and x is a 1-to-1 to t. It's just equal to it. Therefore, our limits remain the same because now this is simply, 0t to 2. If it were 2t or something, you would have to work around that and make sure all your limits remain the same. So you'd have to do some, algebra stuff there to fix that up. But we didn't have to here. So then after that, we do, yet again, so these aren't all too different from what we did previously. It's just a little bit of a different method near the end. But what you then do is you take your parameterized, your x and your y, and you plug them into your equation here, your original equation, which what I've been calling it once you plug them in is your synthesized equation. So then if you do, t cubed over t squared over 2, when you work that out, that works out to be 2t. So now you have 2t. So that's your synthesized equation. Then you go from there. Your next step is to make yourself an r of t function if you want to do it that way. You're like I of j to get your v. And here you simply just take, your xt is your I component, and then your yt is your j component. Therefore, you would work out something that's ti plus t squared over 2j. Take the derivative of it like we did in the last question. That gets you I plus 2t over 2j, which is just I plus tj. Then you do the magnitude of your derivative function, which is the magnitude of v like we did previously. And that's going to give you the square root of 1 plus t squared. We know that the limits are 0 to 2 here. And now we have what we need to do to finish this question, because we have our synthesized equation, which is 2t. And then we have our magnitude of our derivative of our r of t, which in this equation is a synthesized r of t as well. We had to make it up. In the previous question, we were given an r of t, but in this one, we had to make one. So that works out to be the integral from 0 to 2 of 2t square root 1 plus t squared dt. So then you do that integral, and textbook wise, the answer is 10 root 5 minus 2 over 3. So I did,
I got that.
yeah, I did 0 to 3 like a chimp. So 0 to 2, if I were to replug everything in at the end, yes. It is 10 root 5 minus 2 over 3 instead. Jeffrey, do you follow for that? Do you see the logic behind why that's the answer now?
Yeah.
All right, cool. So this problem
took-
is very similar to the last one.
Yeah.
Same process towards the
I
end.
took-
It's just the starting point's different.
Yeah, what I got wrong is I took the derivative of y and said that is equal to 2t instead of canceling out and just being t. The
So
2
you
and the
doubled
1
it
half
somewhere.
canceling out.
Yeah.
Yep.
Well, there's that.
And that just throws all your math off.
Monkey wrench
Because then your u is 1 plus 4t squared.
for the integration part. U sub.
And then it's there. Then it's there.
Bada bing. This one is a beautiful U sub
Bada
though. I like it. Perfect U sub. All right. So we did that
If
one.
you
That
do
was
it right.
27. Yeah, if you do it right. So we
Mine
did
was
27.
not very nice.
I like how we did this one, which is later than these, because of the way the book's designed. Either way, so line integrals over plane curves. So this, if I'm not mistaken, this is probably the exact same process. Just that's in this one, I think it's even easier because look, find the line integral of given function. I'm looking at 21 along the curve RT. So this time it just gives you a curve RT with bounds in with respect to t. So this, it looks like all of these are done identically. It's just
Yeah, so
So
one thing to note
yeah, go.
is 21 is a, so 21, 23, and 27 is kind of like the three types of questions they can ask.
Mm.
So one, they give you a vector and say, hey, plot it over this curve. And so with a vector, you just need to take out the I and J coefficients, and
yeah.
that'll be your X and Y and Z. And then also 23 is saying, we'll give you it parameterized already. In this case, it's X equal T squared, Y equals T cubed. And then 27 is the last one where they just give you over a function in terms of Y and X squared over 2.
Yeah, so in
And
order of complexity, or in order of how involved the problems are, 27 has the most extraneous steps, with 21 having the least. 23 in the middle. Because as he said, this is the three models of the three
23
types
is
of
the
problems, right? Is 23
23 easiest
easier?
because it's already parameterized for you.
Well,
So
yeah,
the
but
vector,
the reasoning why I said 23 might have more work is because in 21 you're given the R function, but in 23 you would have to create your own R function, which is one extra step. Because then you'd have to say t squared I plus t cubed j there, and then take your derivative and then your magnitude. So that's why I say it's one step higher, but even then they're very similar. And you could probably do
You're
it in your
right.
head, so it's not too much an issue. But
so
27
what I do is
is definitely the most
Yeah.
involved.
I just do the square root of the derivatives squared in my head.
Yeah.
And then write it out. I don't do
Magnitude
it in my
j.
head.
Yeah, so that's
Yeah.
the easiest way. So all of these are done the same, and the one we did previous 11, and I'm sure this one, except this one is a little more involved because it asks you to do it two different ways. All of these are done with the same fundamental principle, which is that fundamental formula that we worked out earlier, which is, you know, your the integral of your synthesized equation times the magnitude of the derivative of your R equation.
Yes.
So there's
And
that.
for those that are looking at the group me is the first equation on the equation sheet that I wrote.
Easy peasy. All right, so I think that
Or
is
will write.
will, right? Yeah, because time travel, it's what we do. All right, so we have just completed 15.1. So there's that.
Yes.
We did this one already. And gradient fields, we did this one earlier, and gradients fields has a different formula. It's the partial with respect to x, y, z times the derivative, or times the derivative of it distributed across. So this one, of course, is going to spit out xi plus yj plus zk times 1 over x squared plus y squared plus z squared. And that's just what that spits out. You can work it out by hand like we did previously if you want confirmation, and it would be done the same way.
Partial x, y, partial z. I think it's only written how it is on the answer sheet because it's factored out.
Yeah. No, that's exactly what it is. If we were to go back up here, which question was that? This one. This is one we can look at either of these. So it went to x, y, z, and then they factored whatever that's distributed across. And that's exactly what they did. And that's exactly what I just said you could do it as. But you wouldn't necessarily have to unless you're asked to do it that way. So let's continue. So what do we have now? Line integrals of vector fields. How many things are there to do in this one? There's a lot of problems he's circled. Let's go over these and see how many of these are similar problems so we can like pick one. Obviously, we already did this version, gradient field. So now we start with line integrals of vector fields. This is another line integral problem. This is the circulation and flux in the plane. So we'll probably want to work one of these. Yeah, I think since this one has a lot of questions that are circled, I think we should max out at 3 questions since we do have to get to 15. Actually, let's check how long these parts are. Yeah, that's got a lot of questions. And
Yeah.
this has, so we'll max out at 3 to 4 questions each, depending. So we've already done 1 for this portion. Boop.
I wish we had a breakdown of
Yeah, I really do too.
how much it's going to be on the test.
Yeah,
Because if
no,
we're going to spend like a good part of time on it, I would like it to be like 40% of the exam, but we don't know the percentage of grant of the exam.
If I were to take a guess, 15-1 is probably 10-15%, since it's all very similar, formulaic, not too involved. And it's also a subtopic because you need this procedure to do other portions, right? Because then when we're still doing line integrals, but it's more complex applications of line integrals. So I would say this is going to be the least. 15-1's the easiest and probably the least amount of the test. 15-2 has a couple separate topics. It introduces gradient fields. So, and it also does line integrals in combination with gradient fields and other stuff, a lot of other stuff. So because of that, I think this one probably makes up 30%. So this is totaling for, 40 to 45% now. Then, green theorem, this is all about nope, that's the wrong part. So this is all conservative field differential stuff.
Oh yeah.
This is probably, this one kind of reminds me into like how it is probably is another one of those like 15-20% ones. So the running total is maxed out at 65 now if we were to take the higher end. And then the last portion is integrals and vector fields, which I would say probably like brings us to like 85 or something. This all looks like it's like one thing though, so we'll see.
I think 04 and 02 are going to be the biggest.
Yeah, probably.
Where 01 and 03 are just linking.
02 builds on 01 and 04 builds on 03, I think.
Yeah. So, all right. So let's pick which do we want to do? 11? Do we want to do? So I think that this problem and this problem, 13 and 11, are the same topic. So we'll pick one of these. So this one is find the line integrals of f. No, that is not. No, it is. Yeah, no, it is. Okay. Well, find the line integrals of f from 0, 0, 0 to 1, 1, 1 over each of the following paths in the accompanying figure. Oh, what? Oh, wait, these are huge.
Let's do 13 because I want one problem.
Yeah, agree. In exercise, find the line integrals across a given path C here. So, all right. So
they are very similar, but let's just go over how to set up 11. Where 11 is going to be your f is going to be your main function that you're going to plug into, and then you're going to parameterize that. And yes,
yeah,
you're going to parameterize it And I think this is when you do the dot product. No, you don't. No,
Yeah,
you
couldn't
don't.
we,
You can't
couldn't we just reduce it out once we parameterize and sum it into all t's, right? Or no?
Yes.
No, yeah, I feel like that's a yeah. But we'll see. I mean,
Yes.
so yeah. So it's just it gives us the bounds across all, X, Y, Z's there. And it's
Yeah.
just giving us a variety of paths there. So it just gives us so the change here is across our R for each of these. Except C is a little wackier because it doesn't give us an R. Instead, it gives us several line segments, which is a bit annoying.
So that's not bad. You just need to do 1 and 1. You basically need to do the problem twice and then add the results.
Yeah. Well, the thing here is
It's not fun.
yeah,
but
it's annoying because you got to do it twice.
Yeah.
But yeah, because it goes C3 to C4. So that's a double, and then C1's direct, and then C2 is a curved path. All right. So for those ones, or a problem like this, where if anything, it would probably just be, on the test, he'll give you your function f, and then he'll give you like 1 or 2 paths, and you'll have to confirm, or you'll just have to prove that they will work it out, and just prove that they end in the same spot or whatever.
they will not equal each other.
They won't equal each other?
Nope.
Okay. Well, we know they end in the same spot, but as you said, they will not equal each other. So you just got to do the process a couple times. But let's just do this one because as Jeffrey said, we don't want to do however many problems this would be, which is 4 if you count C as 2.
Okay, yeah.
So dx, where C, so this one, similar to the last one, since you're given, never mind, it parameterizes it for you. So this is a type 2 problem from earlier. Three. Cool.
Hopefully I'm wrong about this. No, that's fine. No, that's fine.
Anyone else get root 5 as their magnitude?
This seems a little too easy. That's why it's a little too easy. Okay.
This one, 13 is just easy just because by virtue of what it is, it's nothing super complex.
I will say there is a trick in here, and it's not the best.
Now I'm scared because I don't see the need for a trick. We'll discuss
You have
it
to
later.
Okay.
We'll discuss it once we talk answers, I suppose.
Yeah, let me get the right answer. And this problem won't affect it, but I have a sneaking suspicion that it will in the future. Oh no. Oh, I got -3/2 root 5.
Hmm.
That's not
Okay.
right.
I got really close, but not quite. So I got -15 root 5 over 2. The answer is
Root 2.
-15 over 2.
Eh.
Where I obviously somehow managed to go wrong is in the construction of my magnitude multiplier.
I didn't even use magnitude on this problem. You said it is negative 15/2.
If we don't use magnitude, then that's the right answer because the magnitude is what added that root 5 for me.
Yeah, I didn't use magnitude at all.
So why are we allowed to not use
Okay,
magnitude?
so x equals t,
Mm.
and so I literally just did this like a
D
basic
of x equals
integral.
d of t. Yeah.
So like dx equals dt, and then I plugged in x and y. So I got the integral from 0 to 3 of
Legend,
t
absolute
minus
legend.
open parentheses 2t plus 1.
Wait, but how did you get? I'm still 5 off.
Okay,
What?
so here I'll explain because now that I know I don't need to use the magnitude, I can explain the other part pretty quickly and easily. So we start off with our synthesized equation, so we have to make that. So you plug in your x and your y, and you will get t minus 2t minus 1. Combine it, you'll get negative t minus 1.
I'm a dumb.
So negative t minus
That's why I
1, yeah, negative t minus 1, and then you just integrate that, 0 to 3, and that's it. Me, I did an extra step which made me wrong, because as he said, the trick here that Jeffrey discovered is since x is equal to t, you can directly transmit dx into a dt with no extra work. But in previous problems, it was like a ds instead of a dx or something. So we couldn't do that, and we had to do it the old-fashioned way, multiply by the magnitude of the derivative of our r. So in this case, I
Yes.
still constructed an r, but it's an extraneous thing. You don't need to do that because if you do that, you'll be wrong. Because in this case, it's directly substitution or you can directly substitute and solve.
This is why you have to pay attention to your differentials.
Shh, silence, Jeffrey. I don't want to hear it from you, man.
And this is important because if it wasn't x is equal to t, it will not be dx equal to dt. So
Yeah.
you have to take the derivative implicitly for x.
Or if it were a ds instead, then you'd have to make an r function and then get the magnitude of it,
Yeah.
which in this case, the magnitude was root 5, which was useless in this
Now.
case, but that's just how it be.
We do that because ds is equal to the magnitude of dt, the magnitude of our velocity vector times dt.
Yes.
He did a derivation of it. I don't remember it, but
We don't
that's
need
how
it.
it comes
That's
about.
just why ds
Yeah.
exists. Yeah, ds exists because all we need to know is the formula. This is not a theory class. That's all I gotta say. All right, so we did that one. So now this instantly goes back up to the top and then scrolls down. So we can find the work done by f over the curve. We can do line integrals in a plane. And then there's vector fields in a plane. There's work circulation flux in a plane, and flux across a triangle. So we have to pick like 2 of these things to do. So let's just do work because I feel like this is pretty easy, right? It's just it's what we just did with an additional step, or no?
Integral work would just be integral of f ds, right?
So for work in the direction of increasing t, yeah, okay, yeah. So obviously we're doing 21 here. So we have our f and we have our r function and we have our stuff. So we've already been essentially given parameters and such, and we've been given limits. So then I feel like we would just go through and do what we just did, find our number or whatever. Is that it?
Yep.
But so it's literally just the same thing. That number is the work. Or is there an extra? I feel like there has to be an extra step here, or is it literally just another application of the same problem?
I don't know. We can work it out real quick.
Integral of fds.
Yeah. So let's do it like we would have done the previous problem. And then we can check if the number matches the answer sheet. If it does, that means that it's literally the same process.
Anyone else getting integration parts? That's why I just threw up.
Oh, no,
That's why.
I didn't. But I might be wrong, so who knows?
What did you get? What did you get for your magnitude?
So the magnitude, so you start with your R, you
No,
take
it's
the,
I
one.
got √2
yeah,
for
it's
magnitude.
yeah, it's 1 plus 1 because cosine squared plus or cosine squared minus sine squared is equal to 1 plus 1. That's what I have √2.
I was a dumb.
You
I did
thought
not take the
integration by
derivative.
parts, gang.
Yeah, because I thought that it. I thought the magnitude was t, so then you would get sine t of t, sine of t. Anyway,
That's how it be.
that is not the case, so I can not do integration by parts.
This is problem 21.
Yes. What?
Well, the god's wisdom decided 21, being an odd, should not show up in the answer sheet. Kind of
And dude, they
cringe,
can work all the problems, but they don't know the difference between odd and even.
I suppose. But here's something that we can find. So
What
I
do you
can look
get?
back. I got 2 pi squared √2.
Yo, let's go.
Okay, so we
Wait,
both have
15.2.
15. Yeah,
21
15.
is negative pi.
You see 21 where?
Yo, I'll check the back on my book.
Are you on the book or are you on the PDF he gave?
I'm on the
PDF
book.
he gave, but yeah, it's 15.2, and you just scroll down and then you go to the left. And 15.21 is negative pi, and I did get negative pi.
I didn't get negative pi either. So yeah, I see it now. I see 21 hidden. So let's see. I didn't get negative pi either. Me and Jeffrey have the same number. So looking at this, so this is in the work section from 19 to 22. So on the right hand side, there is wait, no, never mind. Yeah, that's still 15.2. It's not going to give us any help there.
5.221.
Yes, 15.2.
How does this give negative 56?
What? It's negative pi.
The same. Oh,
Yeah.
I did 5.2, not 15.2.
So it's negative pi. So
It's right
me and Jeffrey have
couple
2
hundred
pi
pages
squared
off.
√2. So let's think here. There's obviously a secondary step to be done somewhere, or we're just trash.
2 √2 pi squared minus 2 √2.
Mine is I have 2 pi squared √2 as my overall answer
And I got the same.
because the magnitude is √2. So as you do, carry it over to the front of the integral for later. And then my synthesized function is negative cosine t plus sine t plus t squared over 2.
Yeah.
And since we're working, we have to
Wait,
do
why
both
is it that?
sides. Why is it that?
You
Why is
take the
your-
integral of t plus sine t plus cosine t dt.
So
Oh yeah, sorry. Negative cosine plus sine t plus
t
1/2 t
squared.
squared.
Yeah. So that's what I have there. So then that is gonna work out. So first things first, 0 and 2 pi, both values of if you were to put both of those into sine evaluates to 0 both sides. So you can eliminate that from the integral portion. Then
Oh wait, now I got it. Now I got it.
yeah,
Sorry.
no, but the thing, so
I-
I'm trying to figure out how we get to negative pi here. We got to be missing a step.
Okay, so
Yeah, so I don't think that there's anything wrong with our algebra up to this point. I feel like somehow, somewhere, there's got to be another step or an intermediate step that we didn't do. So let's see. Find the work done by f of the curve. So let's see if the internet has anything to say about this problem set. Shall we? He just added new files. He just added new
Did he?
files. Yeah, I just got the notification he added new files. I'm gonna check that out.
Yo, then we're gonna
Is
realize
it a
that
topic breakdown?
spending an hour on isn't even on the test.
I don't see. I'm gonna go into my phone and see what the new files added are, because that'll directly allow me to see what he added. No clue. Who cares? Couldn't tell you. All right, let's look over here now. All right, I found an example of this. It looks like. So let's see how this is done. So work is defined as the integral of a curve of f times, what is that? D what?
Probably distance.
It's a differential. D something.
Dx, ds.
It looks like it's dt. But let's see. This person did it by dot product.
That is another way to do it.
But is it? Let's see. Well, let's try it
I
this way.
try-
So this method,
What is the dot product of though?
so it's a dot product between your synthesized. It's the dot product between your synthesized and is this the derivative? And your derivative of R. So synthesize and derivative of R. So let's try it that way then. So this is going to be sine t I plus cosine t j plus.
Are you sure you
Wait a
add
second.
into the f right?
I just booked. I did it backwards there.
Ti.
So now let's try this again. T I plus sine t j plus cosine t k is the first half of our dot product times the derivative of our r, or dot product, the derivative of our r, which is going to be what we did previous, which is going to be negative sine t
Yeah, I
I
got something that I don't like.
plus cosine t j plus k. There's that. All right, so we dot product this out. We go boop, negative t sine t.
I believe this is what you do when you have a function given it in a vector. So you take the dot product of the two. And multiply by the magnitude.
I think I see why Jeffrey's not happy.
Oh, you got to the integral of sine cosine? Fun.
Dude, I have to search up the integral of
Okay,
sine.
okay. Did everyone get like across the board, like negative t sine t plus cosine t sine t plus t cosine t?
I got t cosine t minus sine squared t plus cosine t.
Where'd you get the sine squared t from?
The sine t times negative sine t.
How'd you pull that one off?
I did not get that.
It's a cosine. Remember, you got to take the derivative of the r function.
R function.
So it flips. That j becomes a negative sign.
I screwed up the entire thing then.
Wait, what am I
Right.
doing? What am I looking
I think
at?
the main thing is that we're going to run in a
Didn't screw
problem
that
with
up.
J. I think the other two aren't bad.
Oh, wait a second. I boom. They should.
Oh, is this?
I messed up somewhere. So T. What am I doing?
Okay, so
We just do the we just do the derivative of r, and I can't seem to wrap my head around doing the derivative of r right now. So the derivative of sine t is just
Cosine t.
cosine,
I,
and
beautiful,
that's I.
plus or minus the derivative of sine or minus sine t j.
Yes.
Sine
And then
t,
it-
the negative sine t.
Negative sine t, and then
And-
it's just k or
Yes.
1.
And then
Okay,
t is 1. Yes.
you dot product this, and you will get t
Cosine t times
cosine
t.
t, yes,
Yes.
plus
Minus sine
minus.
squared t.
Now, yep, now I'm gonna minus sine squared t, and then just plus
Plus.
cosine t.
Yes.
Yes.
Okay, beautiful. Now we
Except
take
it's
the
not.
integral.
And that is a scalar.
Yeah, so it's just
So-
sum. It's just summed together, and then we have to take the integral of this, right? Yes, with respect to t,
Yes.
from 0 to 2 pi.
0 to 5. So that's when we go to integral calculator, and then
How does one take the integral? Sine squared t definitely is something we've seen before.
Yeah, I look that one up every time it pops up on MML. It's like 1/4 something plus something something plus c.
We just need to evaluate this integral, and if it's negative pi, we know from here on out. Because I'm gonna be real, I honestly don't think a problem of this level of complexity would show up for us to
I
do
don't
by
think
hand
he's.
in a time.
I don't think he forces us to know any trig identity other than sine squared plus cosine
Yeah.
squared equals 1.
So hopefully this
He
works
stayed
out to
away
be
from
negative
like
pi.
all the hard integrals for like the other 3 tests.
John, it's up to you to confirm whether or not it's negative pi.
oh, I'm already going on integral calculator.
He's chugging it. He knows how it's done.
Yeah. Options
I have a
0 to pi. P. And away we go. Now we just use the data farm. And it gets negative pi, brothers.
Yes! Yeah!
Yeah.
Whoa! Yeah! Okay, we now know how to do work. It looks like for the work ones, and if we look, every single work problem is dot product. So I think that's how you have to do it.
Yeah, that makes
Mhm.
more sense then.
All right, gang stars. When it comes to work, it's the dot product of your synthesized.
So Jonathan's
times the
leaking the
derivative of R.
formula sheet out, right?
Yeah, he's leaking his formula sheet. So the formula sheet for this one is going to be.
I ain't
the-
keeping up.
yeah, it's gonna
Equation
be-
3.
Yeah, equation 3 is going to be the integral with respect to c or whatever, which is just going to be what it gives you, of your f of t, your synthesized equation. You should probably put a star and denote that it's going to be a vector dot product. But then just like it's going to be your synthesized ft dot product with the derivative of r or your v, and there you go. Is my door like smashing from the fan? No, it's open. Why is my door open? How'd that happen? That's sus. All right. Sus. All right.
Hey, lock the door.
I don't have a lock on my door. It doesn't work. It's broken. It's been broken for years.
My brother wanted to come into my room one day, so he just leaned on my door and it popped open. It was locked, but it's fine.
Legend.
So now I don't have a lock on my door.
Yeah, exactly. Legend. All right.
Fun
So
times.
we did work, and we now know how to do work problems. And there are a couple more. There are a lot more problems here. This is another work problem, but this is work, circulation, and flux in the plane. Work. Find the work done by the force, your F again, over a straight line. So this would just be creating an R. I don't want to look at these. I don't.
Like he doesn't circle like the flux once there because like, do we even go over flux before like 0.4?
He circled the work ones, but skipped the flux ones. So I think we're gonna just, and when it comes to work, we know how to do a work problem, but I think the difference here is that it's in a plane or whatever, maybe. So we'll just do this one. We'll do line integrals in a plane and then move to O3. We only have so much time. It's a shame this is the last test, because otherwise I feel like an improvement upon this would be having a predetermined list of topics and then setting up a poll to determine which topics the students feel least comfortable with.
See, there are things where I feel I'm good at, and then I come here and it's like, no.
Yeah, well, the thing is, like, what's great about this is the fact that, first of all, the test is 4 days away, 3 days away. Second of all, you know, doing some practice problems is going to refresh and we can rewatch it if needed. And like, third of all, you know, once we know this is going to give us an exact map of what we're garbage at. So we know exactly what to focus all of our time on in preparation for the test. All right, we'll do 25 then. We're going to figure out how to do line integrals in a plane, and then we're going to go on to O3 and suffer. 25. What's funnier than 24? 25.
25. You know the joke behind that?
No. What is it? Is it safe for
24
school?
was Disney Channel on cable.
Ah, okay, it is
Yeah.
school safe, of course it is.
So 25 is Nickelodeon. So
Yeah,
what's
that is
funnier than
kinda-
Disney Channel? Nickelodeon.
That's
And
kind of
that's what
alpha.
Nickelodeon said.
Literally casting shade. All right.
Oh yeah.
So we have a vector field defined. Seems simply, but no, because then you see the word counterclockwise and you want to suffer. CC.
Wait, is it not
Twice just means
counterclockwise?
correct.
Wait, hell, what the hell am I reading? All right, I'm looking at 26 like a G.
25? 25?
Yeah, we're looking at 25 now. That's what's supposed to be looked at.
What's T?
Okay. Along the curve, x is equal to y squared from 2 points. So it looks like we'll probably have to define our own bounds here.
Or you just set stuff in terms of t.
Yeah, so, well, I guess we can define, do you want to define y equal to t and then x is equal to t squared?
That's what I'm doing.
Easy peasy. T squared. And then we'll also have to reevaluate our limits based on that principle. So our new points are going to be, you know, 16, 2, and the other one stays the same.
Now what's capital T?
I'll remember.
Couldn't tell you. All right.
I think it ends up just being like the integral of f, like something.
I
Like,
mean,
You can
obviously,
make the t cancel out or something.
I know that we know how to do the f part because we've been doing it this whole time. F is obviously going to be our
This is just
synthesizer.
flow.
What does that mean?
Like,
Yes,
flow
just
flux.
flow.
This is just flow.
Can you define that,
Oh,
or
Of course.
is that just a thing?
So this is
There you
like
go.
15.4 Green's theorem stuff. That's all I know it as. Except I don't really know how to pull that from you. Actually, I think I do. Maybe.
Is T the normal vector?
Probably, since it's about planes. If I had to take a gander.
Oh,
Oh. All right, let me.
No.
Okay. I found a similar example. I'm gonna look at it and see what happens.
yes. So
I don't know how to set up the
it looks like green theorems 1, It looks like Green's theorem 1.
The hell does that mean?
Circulation. It means it means, what is it? What's the little integral with the little circle, closed integral of force? Wait, no, this is just the open. This is just regular integral. So
What is t? All we want to know is what t is.
T is your derivative of R with respect to T.
Oh, okay. So is this the exact same thing we've been doing again?
I think so.
Okay.
Are we just gonna do it okay, let's do it.
We'll do what we did last
Okay,
time.
so-
dt.
So what do we got? T is from 0 to 1. Let's just, what is that? X is equal, Y is equal.
Is
Nah,
negative
nah,
1
it
to
gave
2.
us points, nerd.
Y is equal to T and X is equal to T squared. So,
It's -1 to 2, as
Oh,
Jeffrey
that's gonna-
said. Okay, if this is the case,
not-
we have a parameterization, we can start
Right.
synthesizing. The
Yes,
question
yes, it
is,
is.
do we do the dot product here or no?
I just don't know how you get the
Technically-
other thing to dot with.
You can construct an R out of your parameterizations. In this case, it would be t squared I plus tj.
Okay.
So that's something you'll need to know for all of them. But yeah, you can construct an R whenever you need, because by virtue of being able to deconstruct R, that means you can inversely construct it from the same information.
So we
So-
got T to the 4th I minus,
Oh, you're just speed
T,
demon.
J.
Did you do the dot product version?
just
I'm doing
about to
dot
do the dot
product.
product. That was just F in forms of T. And then T in forms of T. Well, wait, why is there T in DS? We multiply it by the magnitude. That's what we do.
Again. Beautiful. So
Okay.
wait, so we're not doing the dot product here? So we're doing the
No,
other
we
one?
are. We're gonna do the dot product and then no, it's both of them. It's both of them, Ethan.
It's a
We're
mix?
marrying them now.
Okay, so we
Yeah,
have.
so we're gonna do the dot product and then multiply it by the
So what's 2 to the 6th?
magnitude.
C4.
What did you
uh,
say?
2 to the 6 is 2, 4, 8, 16, 32, 64, 64.
Disgusting.
But why do you? What?
Yeah,
Oh, I see
where'd
where
you-
you're at. I see where you're at. 2
So
to the
then you
5th, 2 to
dotted
the
it.
6th.
You dotted it with your R, which we define here. R or the dot. It should be the derivative. So what is it going to be? It's going to be 2t I plus j, and then you also multiplied it by the magnitude of that, which is
Yep.
Which is the square root of 4t squared plus 1. Okay, then, and then integral that whole thing.
About 117/6.
Shh. No one needs to know.
Wait, so for the magnitude, did you get 4t squared plus 1?
What?
I'm in the process of suffering.
Dot product.
The magnitude, I got square root of 4t squared plus 1.
Yes, that's what I got as well.
Ew.
So.
I can't tell if it's gonna be cool anymore.
I don't think it's cash money.
No, I don't think it's cash money at all.
I'm gonna be honest with you.
Let's. Jeff, you said you had a number?
Yeah, 117/6.
What is this one?
It's -39/2.
I didn't
Okay.
get
Jeff, did you do multiplying by magnitude as well, or just the dot product?
product.
Okay, so maybe multiplying by magnitude is the hidden link. I hope.
People thinking we have our stuff together.
I mean, we technically
Uh.
do. It's just wow, I'm on the wrong. There we are. This PDF.
Oh, no, it is. It's good. It's Gucci. It's not nice, but it's Gucci. So
What do you mean as in it spit out the right answer, or as in it's just it's trash?
I think it's workable. No,
So I have,
no, how?
as of now, I have 2t to the 5th power plus t squared times the square root of 4t squared plus 1. Now,
Integral graph.
obviously, 4t squared plus 1 could be written as, you know, parentheses to the 1/2 power. But
Is this the second time I'm using an integral calculator? Yes. Gonna be
probably
the last time?
doing
No.
this manually. This one also seems kind of absurd to do manually, like on the fly, but oh.
Well, at this point, I just want to know if we're doing the right
Yeah,
thing.
it's more about process because, as I just said, it's unlikely they'd be this difficult. It'd be more manageable to do quickly.
As long as you do the right process, you'll get like what, half credit or something.
Well, yeah. Well, if your skills are lacking or you're losing points on like computational stuff, I don't think he cares as much as, like, as you just said, process matters a lot. And so, Jeff, you went from -1 to 2. Those are your limits?
Yeah.
Well, obviously that's what I got when I converted, because, you know, y doesn't even change. So maybe we'll see. Hopefully that's the right limits to go. But looking at this,
So what's your final what's your final integral?
before I integrate,
Integral of 2t to the 5th minus t.
yeah, because the only difference is he's not doing multiplying by magnitude.
What is, so I got 2t to the 5th minus t times the square root of 4t squared plus 1.
How'd you get minus t?
The dot product of negative t times 1.
Yeah, you're right. Yours is right.
It's not right either.
Didn't spit out the right number.
No, machine go burr, and it was like 211 times 17 to the 30 halves plus 5 to the 5 halves over 210.
Yeah, I doubt that's -39 over 2.
But it might be. That's all I need. Let's try it. You plug it into a calculator, give me in decimal.
70.69.
Rip. It's -19.5. What is wrong here? Let's see. I found an
Oh,
example.
probably we don't know what t is.
Maybe. But looking at so here I found an example problem of this, which is extremely similar, in which the f is 2xyi plus 2yj minus 2yzk. So it's got 3 dimensions here. And then the r is ti plus t squared j plus tk. And then it's going from 0 to 1. Wait,
Okay.
this is the wrong question, right? No, it's the right question. Which one are we even doing? We're doing 25. No, I'm on the wrong thing again. We're doing 25.
Because the book says integral of f dot TDS is the same thing as the flow integral or circulation. Which
Okay, you
I
keep on
only
saying that,
remember.
and I'm like, good for you, Jeffrey. And I'm like, that
Yeah,
does not help me.
Yeah, I don't know what that means.
I only remember doing
You're just like, oh,
flow
it's the
and stuff
flow.
with
And I'm
Green's
like,
theorem.
What is the
Which-
flow integral?
It's like you take the partial of like n with respect to x minus partial of m with respect to y.
Oh, that I kind of know what you're talking about.
I was about to be like,
I remember it from the
but I'm
homework.
like,
So they did so integral of of c or whatever f times t ds is their formula, and that becomes f times the derivative of r, and they got, oh boy, so it's not even a, is it a dot product? It should be a dot product. All right, I'm gonna try it that way by hand real quick. I'm gonna do the dot product method as well and leave out the magnitude, and let's see what happens. So f is just simply gonna be equal to, t to the fourth I minus tj. dr is going to be equal to 2ti plus.
So the capital is the tangent vectors, by the way.
Tangent vector. Is that, what does that mean?
Well, the tangent vector is tangent to the plane. So that's good. So it's also
Yay.
it's probably like the square root of like normal vector times I'm looking. I'm reading the book.
Figuring it out.
I'm on page
Figuring it out.
835.
I'm on 830. But Jeffrey's like 5 pages ahead of me. Fine.
Like examples 835, I think is what you're looking for.
Okay, let's speed ahead. Oh, 831 is. Did they bamboozle us?
Jeffrey, did you get 40?
No,
I just got 40.
about 117/6.
Wait, what'd you get?
117/6. Yo, wait, that simplifies.
You cringe nerd. That's the right answer.
Wait. Is it?
Wait, no, but your sign's off. It's
My
negative.
sign's off, but that's 39.
Fix your
over 2.
sign.
Wait. I have a
I don't
question.
know where the sign's
Did you do
wrong.
it from -1 to 2 or 2 to -1?
-1 to 2. Like -1 is the bottom.
It's 2 to -1. But if you use the fundamental theorem of calculus,
You
can take
flipped
out
the
the negative
sign.
and
Just
flip
flip it. Okay.
once -1
Easy
to 2.
problem.
Easy clap. Okay, so what you did was you did,
I did the dot product.
You did the dot product. So your f was t to the fourth I minus
TJ.
tj. And then your dr was 2ti plus tj or plus j. There's my mistake. I did
So
TJ.
it's 2t to the 5th minus t is like your integral.
Yes.
After the dot.
My homie Jeffrey just
Great
realized
that.
I refuse to
I
simplify my
I
fraction.
didn't realize 117 was divisible by 3 until I'm like, wait.
Oh my god.
Add up all the.
Yeah,
117
I
doesn't
know,
look
but
like
I
that.
didn't think about it. I looked at it and I'm like, nah, no.
All right. So the one thing that's slightly unclear, but will be cleared up momentarily, is the reasoning behind why we flip it. And the reasoning behind why we flip it is because -1 is our second point. So as John said, it should start with 2 to -1, flip it to get our sign change.
Yep. And so we do that by saying y is equal to t. And so t is equal to y. So we can just say that since it starts at 2y, we can say that's our starting point for t. And then since it ends at -1y, I don't know, then we can say that that's our ending point for t. So it goes from 2 to -1t.
And then, as you said, fundamental theorem, flip it, and then it goes negative. And this would have been a lot faster if Jeff knew how to divide by 3, but
Oh, 3 still can't figure out grade 4 math.
that's how it be sometimes. All right, and with that, we conclude this section for now.
Heck yes.
That's how it's gonna
I
be.
guess we still got 2 more sections. Let's be
I think we might have to. So I don't know. There's no like running length on the recording, but I think it's approaching an hour, like an hour and a half to 2 hours. So we should try and keep it below 2.5 hours to the best of our ability. So we'll probably do like 1 or 2 from each of these because these are pretty extensive. Although
The
as you
path
said,
independence, I think, is easy.
all right, well let's get it. This is all example stuff. All right, so he circled a lot of conservative. This is potential function. So he has literally 4 questions of potential function circled. Let's take that as a guarantee it's going to show up. So in exercises 7 to 12, find a potential function f for the field f. Okay,
This stuff is easy. It's just
let's chug in through then. Let's just arbitrarily pick 9. F is equal to ey plus 2z times I plus xj plus 2xk. All right. I don't
So-
remember these too well. I think I remember it from the homework a little bit. So let's see. So isn't the first step to distribute?
I just, make educated guesses and they usually turn out right.
Not everyone in our class is so
Avalon
fortunate.
and Jeffrey. Just be like, yeah, just guess and get it right. Well,
I think I got it right.
He's built different. So by any chance,
I got it.
is it xey plus 2z? Yes? Or no?
So basically, all you need is your function. That way, when you take the partials of it, you get the ijk components.
Oh my god, I was right. Jeffrey's right. You can just guess.
Like, as long as you know how to guess, it's easy.
Okay. So, because here, there was the first question I did on tonight's homework was this, and I was able to guess it right as well. So let's think about this and understand why we can guess for easier ones.
you just integrate it, right?
Yeah. So it's one of those things where you do the partial per. So it's like partial x for I, partial y for j, partial z for k. So you go across this thing, and you'll have you obviously distribute to start. So your I, you just add an x. Your j, nothing changes on it. It just stays the same because ey is just gonna be 1. And then the last one, partial z, you carry a 2 out or whatever. But then later, when you integrate, it's gonna cause it to divide out. So you lose the coefficient on the front of the term. I don't know why it's only z that affects.
Well, if
with
you look,
z,
in
when you
this
take
one,
the
it just looks
partial,
like
you
you
have to
integrate it
multiply
all.
by 2.
Yeah, that's why. It's because the only one that's affected by a new constant coefficient is z. Non 1, because 1 technically happened.
Okay.
What are all these nerds in the circuits chat freaking out about? There's a quiz tomorrow in circuits and everyone's having a heart attack. They're like 10 points. They're not
Oh,
even
Dr. Strong.
strong. No,
Isn't it Dr. Strong?
No, I have it's circuits. I have Bowman. Easy B. Bowman's a legend. All right.
Wait, so I'm confused. So I just integrated all of them and I got the right answer. Like the integration of 2x is x squared, and that's the answer. Integration of 3y is 3y squared over 2. That's the answer.
What are you talking about 3y squared? How is that the answer for this one is x ey plus 2z, right? Plus c.
Wait, for 15.3,
15.3 number 9 should be x ey plus 2z.
oh, I'm looking at
Yeah,
7.
yeah.
Might
So
be.
the starting process here is you take the partial derivative with respect to each, and then you know, you look around. I don't actually.
Seven's like,
I definitely can explain why it's correct, but I just know how to guess.
these, it's really hard to explain without showing. But once you understand how the guessing works, it's easy. Because it's not really guessing. It's like, I don't know, good guessing.
Educated guessing.
Nah, it's just good guessing.
See if I can find. Let's see if I can find. Yeah, I found an exact.
Jeffrey's know it about how to get
No,
good.
I found someone who worked through it proper, so I can kind of try and figure it out a bit better. There's a conservative field. So what is it? The first thing you want to do is verify its conservative field. That's what the sure.
Yeah, don't verify.
It is.
We're just gonna assume that whoever is
is.
gonna give it to us is gonna be nice and not.
Yes. Bada bing, bada boom. All right, so there's that whole thing, and then you integrate with respect. So you integrate the first thing with respect to. Oh, this is super long to do by hand. The guessing is alpha as hell. Is all I gotta say. So let's see. This means that when hz is equal to 0 and hz is equal to c, where c is the desired potential function, the given vector field would be that. Why is it that? So yeah, I get the part where we have the x, y, and z. That's easy peasy. That's the partial part that we discussed earlier. Then you take each of those and integrate it with respect to its variable. Right, let's see. Yes, okay. So you integrate it with respect. So you take the I component, which would be ey plus 2z, integrate it with respect to x, and you will get x ey plus 2z plus g of y of z for your constant there because of rules. Then you take the next one, which is x ey plus 2z, which is technically the x portion, and you integrate it with respect to y.
Oh, okay.
And it gives itself minus the gy function. Therefore, gy is equal to 0, and gy is z is whatever. And then you do the next part. You take the final portion, the z portion, you integrate it. Well, no, then it's plus hc, and then you do this whole thing. It's like a weird daisy chain. This is really complex
Yes,
for what it is.
this is the one where you
like do problems like 1 and 2 on the homework and like understand how you can get the answer straight from the question.
Or just guess. Alpha style. Although, let's be real, he won't let us just guess on the test. You
didn't show your work? 0.
Like, as long as you show your answers correct, like, it's a right method, right?
I mean, something about
guessing
how
check, he does not like guessing check.
Something about how
not like
because I was able to guess it as well after I recognized it was the homework problem. So there's something intrinsic about how I've seen it done before. I did it once, and I understand that. Although here's the thing, I can only guess that way because of the form of the question, because it's an e to the term question. I couldn't do this same guessing method in my head. I couldn't do it the same for 10 or 8 or 7. Either way, screw it. I don't care. It's almost bedtime. Let's keep going. People, this is a guideline. People can study more when it's cram time. Know what I'm saying?
Cram.
Yeah.
Oh my.
I have more
Oh,
things to worry about. On top of the fact I have 3 exams this week, plus a quiz, plus a homework assignment, plus. All right.
oh, I have an exam due tonight, but I texted my professor and I was like, can I please have an extension? My grandma died. And I'm like,
Did it work?
sort of. She's saying that she's having problems with the exam and she'll let me know. So,
Alpha. All right.
but fun fact, my grandma did die, so I did not lie about that. So
That's big sad. I was
Kinda
gonna
sad.
say for a second, I'm like, you're not lying, are you? Yeah, that's pretty shit.
no, that's why I'm home right now.
I thought you were
So-
home because of COVID considerations. All right, let's get it
No.
going. Let's finish the
I
grind.
was a pallbearer for my grandma's funeral yesterday.
Absolute legend. Was it a nice funeral? Was it a nice service?
It was not bad. A lot of crying, but that's par for the course.
Indeed. All right. We have to pick one of these exact differential forms questions to do. I've reached the point where I have absolutely no clue what's happening for anything. So
Be the same type of guessing. Like
show that the differential forms of the integrals are exact, then evaluate the integrals. How does one show?
they're exact because they have a dx, a dy, and a dz.
Is that it?
Yeah, basic.
That.
It's in the integral of mdx plus ndy plus pdz
Okay.
form. Therefore, it is
Don't play with
exact.
my heart, Jeffrey.
What?
Don't
Don't
play
make
with
it
my
easy.
heart.
Don't make it easy. Is that are you sure?
Yeah.
All right, we'll go with it. All right. If that's the case, then so we've confirmed that. So then we just evaluate the integral. So what the hell do we do about these points? What does that mean? Does that mean we evaluate each of these, like we evaluate the 2x dx portion
So
by its specific?
What you have to do is you have to get your function of like your x, y, z. So basically, you just take the integral of each of these.
Mm.
So like 13, you get x squared plus y squared plus z squared,
Yep.
and you just plug
Oh
in.
my word.
And then you integrate what?
It's-
So your x
it's
squared
right.
0 to 2, y squared is 0 to 3, and z squared
Because if you think about it, you can just split this up into 3 different integrals for the x, y, and z.
So that's
But
it.
at least for 13. But for stuff like 15, where it's like mixed letters in there, that's why you need to get your function in terms of all 3. But it's just guessing, really.
All right, we won't do differential forms.
Just Chad Jeffrey over here.
Guess it. Guess it. All right. Although they are not defined on all space R cubed, what is this? Finding potential functions to evaluate line integrals. Although they are not defined on all space R cubed, the fields associated with exercise 18th. Okay, so it tells us they're conservative, so none of that stupid checking. Find a potential function for each field. So we did potential functions earlier. What we just did.
Potential
For the people who
function
are
means-
watching the
John,
yeah, for the people who are watching the video, I'm going to figure out what function to use and put it as equation 4 on my equation sheet.
for what? Finding
or,
potential
like-
functions or differential?
Yeah. Finding potential functions. I'll work one out on the equation sheet and I'll put it as equation 4.
Okay. Find potential functions to evaluate line integrals. So potential function was the guessing that we did previous. So there's a proper method for that, where you do the differential with respect to x, y, z. But this one gives it to us in the form of the previous thing, the differentials, right? This one gave it in the exact differential form, where it's dx has got a dy and a dz. So what does this mean for us then? How does that change the rules? So
it's basically the same thing.
we evaluate it.
Yeah, you find your function in terms of x, y, and z, and then you plug in the points and subtract.
So when you say find the function in terms of x, y, and z, does that mean like this one
potential function.
So I integrate this, I integrate this, I integrate this.
Yeah.
And
You
then
get the
I,
function where when you take the partials, that's what you get.
okay,
So basically what we're gonna do is we're gonna find a function, and then we're going to, that's gonna be a derivative in terms of x. So what we're gonna do is we're gonna pull that out and say, hey, 2x cosine y plus c is one part of the function.
Yeah.
Natural log of y minus plus 2x cosine y
mhm,
is
the next part of the
another,
function.
plus c is the equal to function, and
And then
then
the last one is
natural log of
just,
z
yeah.
is plus c is part of the function. So we do that and then do a little ditty.
So then the one thing I'm unclear on is the evaluation portion. So to evaluate, do we evaluate this part by
But
part?
you get your potential function
Mm.
and you just plug in like your 1 pi over 2 pi, get the result of that, and then you plug in the 0 to 1, get the result of that, and subtract one from the other.
Oh, so the
Like
reasoning
basic
behind why
fundamental
we're,
theorem of calculus.
so the reason we're given these three is because since we're working backwards with multivariables, they all are going to end up remaining, as opposed to traditionally where our multivariables disappear along the road or get replaced by something. So we need all these values.
So
So this
these
is giving
three
us,
little chunks
it's
are
giving
going
us
to
the
integrate
limit.
into one big function, and then through that big function, we're going to evaluate it at that
Yeah,
point.
because to start, this looks like
that
it's
point.
separate, but after integrating it once, you know, dx, dy, dz, those go away. And now we have one, as you said, big function. So then since the big function has components y, x, and z remaining, that means we need limits on all dimensions. And that's what we're given.
Yeah.
Okay.
So like this one is 2x cosine y
So
plus
actually here,
natural log of y
let's try it. Let's try
plus
it.
natural log of z.
Let's do 19 real quick and plug everything in and make sure the numbers are the same as the answer. So starting out, integrate that. It's just going to be x cubed plus ln y. For when there's z squared over y, this is just going to be z squared ln y, right?
Yep.
Yeah, okay, cool. And
2
then
plus z squared ln y.
what the hell is the integral of ln? No, no. No. Oh, we don't need to, thank
No,
God. Never
you
mind. I
just
almost,
plug
yeah,
in
yeah, yeah.
points.
No, I almost died there because I saw the DZ part had ln y. I'm like, how do I do the integral of ln y? It's just z ln z squared ln y, and then we go. So
if
then,
I'm
as you just
right,
said, so on the next part, Jeffrey, we just plug in points here, or do we integrate this again?
You just plug in points.
Okay.
There's
We
no
just
more
plug in
dx,
points.
dy, whatever. You just
Oh,
have your
yeah.
big function.
Oh, so that
because
so
we integrated at every step, so
we
the
just
function we
did.
get is the integrated function.
G.
If that makes sense.
Beautiful. All right. So to start, our upper bound is going to yield.
I got 9 natural log 2.
You got 9 natural log
Yep.
2.
Same.
Yep. That's how it's done, Gangstar. Easy.
Equation number 4 on the equation sheet. I will
Is
write it up.
however
and-
that was done. Just that way. And I mean, as Jeffrey just said, and as we can clearly see, exact differential forms are done the exact same way, at least for an answer. When it comes to the show part, whatever Jeffrey said, we're going to have to take him at his word for it. But, you know, I'll take him at his word for it. He's been right about them, so I'll give it. All right, so this is just a lot of work function potential stuff. But we're basically done with the problems in this set. There's 2 stragglers. There's 27 and 31. 27 is independence of path stuff. It looks like. Show that the values of the integrals in exercises 25 and 26 do not depend. Oh, so it doesn't even include 27. Never mind. It's find a potential function. So to find a potential function here, it's going to be dx, dy, and then do the daisy chain, and then it's going to just spit out something. So we've done that or done a version of it. That was the guessing thing. 31 is evaluating a work integral in two different ways. So this is doing your partials of something with a path in the XY plane, and then this is doing it this way times the dr, or the dot product of the vectors. All right, we're gonna forego these since we're starting to run up on time. We'll pick a couple of these to do, and that'll be our general overview. Oh boy, look at the fancy integral symbols.
Yeah.
Oh no. I'm in danger.
I'm in danger.
Exactly. All right. Yeah, I have no clue what this is. So we'll see. Use green theorems to find the counterclockwise circulation and outward flux for the field and curve C. All right, we have an F and we have a C. In this time though, the C looks like it's given as a geometric shape via bounds.
Okay, so what I've been using for all these problems are the two formulas on page 857.
All right, what may those be?
So it's double integral, the flow or circulation is partial of n with respect to x minus partial of m with respect to y, dx dy.
The hell is that?
So your j component,
Yeah.
your I component is your m. So like the exact form, how is the mi plus nj plus pk.
Okay, so n is
But
I.
with all these, you're just working with mi plus nj.
Okay, so m is x minus y if we're looking at 5.
And then n is y minus x.
Okay, so what is the formula you just said then?
So
a minute.
circulation is the double integral
Okay.
area, basically.
The double
Partial
integral
n
of
with
the-
respect to x.
So are these separate?
Flow and flux are separate, yeah.
Okay, so
Okay,
what'd
I
you just
sent
say? You
a-
said double. Oh, what'd you say?
I sent a PNG in chat of the formula that he's saying.
Oh, I have to open chat. It's hiding.
Oh yeah,
from
I forgot that you don't really see it.
It takes me a sec. Oh boy, this is sus. Are you sure it's safe for me to download? It says math.png.
Definitely not safe.
Oh well, it's too late. All right, I found it as you said. So, as you said, it's the double integral of partial n with respect to x minus partial m with respect to y, dx dy. Okay, there's that. So that's the first formula you said, and that's for curl integral or whatever.
The easy one.
And then what's the second part that we have to do then?
So flux is the double integral of partial m with respect to x plus partial n with respect to y.
Plus
dx
partial
dy.
n with respect to y. So
you take the I term partial with respect to x, and then you add the j term partial with respect to y.
why is that harder?
Easier,
Oh, easier. So
kind
the
of.
only the difference is it flips m and n.
So like in flux, because I think circulation is just how like around it goes. So I
Yeah.
think like with squares, I think circulation ends up being 0.
Okay.
And then I
Math
think flux
two.
is how far out it goes or something. I don't know. So
Well,
like
So all I need to know is the difference between these formulas. So the first formula is double integral partial of n with respect to x minus the partial. Oh wait, what?
yeah, that's
I
right.
sent
Yeah,
math 2 in chat, and it's the other
Oh.
snip. It's a snipping of the other one.
It says sus.
Let's see. Sus number 2.
'Cause it's double the math.
Yep. I didn't know what to call it. I just
How am I unable to?
left on cap locks. It's
Open
just
file.
PNG.
There we go. There we go. All right.
Okay.
Yeah. So it's just that. Yeah. So they flip where the letters are, and then make it an addition
they-
instead of a subtraction.
Yeah.
Yep.
Okay. So in practice, let's look at 5 with the square. So in practice, do we use both of these or one
Yeah.
of these? So why do we use, or how would we use
It
both?
says use Green's theorem to find the counterclockwise circulation and outwards flux. So you need to find the circulation and the flux. You use them separately. It's two
Okay.
problems basically. It's a part A, part B.
Okay.
Circulation is the first one, and outward flux is the second one.
And looking at it, I guess if it's dx dy, that means we have double limits here. And does that mean our x limits are 0, 1 and our y limits are 0, 1?
Yep.
Okay, well, let's work it out. Let's work out 5 and see how it goes using these formulas. So circulation starts. And n is y, or is it n is j or I?
N is J.
Okay, yeah, that's what I thought.
Alphabetical order, M, N, P.
Hmm.
O is skipped because it looks like a 0, a theta, phi, literally every letter to ever exist.
Alpha.
So which one are we doing? 5.
5, yeah,
Okay.
5. Hey Jeff, you got 0 for circulation.
It's a square, so it is expected.
Well, okay, didn't even have to do the double integral. Yeet. Flux it is. I suppose flux is not guaranteed 0 then.
M dy minus n dx, by the way, for flux.
Yeah. I opened up the sketchy math too, because I want all the viruses.
I got 2 for the flux.
Yeah, the number, yeah. And then don't we run the integrals on this? So we do dx with it, so you get 2x evaluated from 0 to 1. Yeah, it's going to be 2 across the board, right? Since we're working with such mundane limits. Let's check the almighty, all-knowing answer sheet. We did, yeah, yep, 5. Flux is 2, circulation is 0. So I came in knowing absolutely nothing about it, and turns out it's just 2 formulas. Easy peasy. All right.
But like the circle on the homework problem, like 10 or something. It's like, yep, nope, not worth the points.
I haven't finished that yet. I have 2 hours, or a little under 2 hours to do it, and I've done 1 question.
I haven't started on it, so, and this is why I have. This is why I choose to not do the MML.
Exactly. I wonder what my MML average
Hey, I
is.
do the MML. I normally get a 50 on it because I started at 11 o'clock at night. On
See, I
Sunday.
usually spend
So-
way too much time on it, so I have an average of like, what, an 80 something.
All right, my MML average is an 85.2. Now,
Mine might be lower. I don't know.
82.26.
yeah, so, but the abomination is that my quiz test average is a 93.67. Disgusting. It's so low. There are probably people watching this like, fuck these people.
Like, shut up, dude.
Yeah, but I mean, yeah, either way. All right.
No,
So
they hear me and I say I'm 102.67 and they're just like, wow.
cringe.
I'm saying a nice 100, you know.
This is
I'm
a
perfect on
solid-
the test, totally. Haven't missed anything.
Not a
No
single
2.86,
point.
they're like, yeah, he screwed something up somewhere.
I love how our collaborative work has like just arbitrary 605 points, even though it's weighted at like nothing in the actual grand scheme of things. Either way, so we now have figured out how to do circulation and flux. Cool.
Yeah,
Yes.
it's not too bad.
So the only thing that I can see that's a little awkward is when the shapes are changed up, like triangle bounded, but you're just gonna have to define your bounds differently. So your dx is defined Oh, they're just gonna be the same, right?
The triangle's pretty easy
Yeah.
to get
'cause-
bounds for.
Yeah, because it's y is equal to x. So then, you just
Mhm.
have to figure out where it is.
But
So
there
you
was
have
a circle problem on the homework, and it's
y
like
equals 0, x equals 3 over here, and then y equals x. So then, yeah, that's really easy. Yeah, you just find
What,
your
Jeffrey? You don't want to convert into polar coordinates?
well, wait,
Never say that
worse
to me.
than that though, because it wasn't even a centered circle.
Nah, you don't need that. It's
I
just a normal
refuse.
circle.
I refuse to use polar, even though my life's gonna be built around polar when I get to signals and stuff. But oh well. 15. This looks like circulation still. Yeah, couldn't care less. We just did that. This is find the work done by function in moving a particle once counterclockwise around the goo. What the
I believe
hell?
I believe work equals flow / circulation based on the one formula from like 15.2
So work is equal to circulation.
circulation.
Okay. Okay, so to find the circulation of this, it says one counterclockwise.
What
Is
are
that
you
the default? What parameter does that counterclockwise thing change, if any?
0 to 2 pi, I think.
Okay. And the given curve is triangular. So we know how to do that.
So I think as long as it's counterclockwise, we're good. If it's clockwise, then we have to take the negative.
I don't know what
Yeah.
happened clockwise.
I think so. My logic in my head makes sense. So
Yeah. I mean, like-
Everything has been counterclockwise forward, so
Let's just assume that it's always counterclockwise, and there is no reason in this entire universe that clockwise would matter.
no, never.
Exactly. All right. So if this is the case, then that would just be calculating circulation. If work is equal to circulation, slap that on the formula sheet. Just say work is equal to circulation.
Okay,
Other than
that
that,
will be asterisks of
yeah.
the next
Yeah.
one.
All right. So, all right. Well, looks like our last topic then is 15.5 on the test. Yes or no?
I don't even remember if
No.
50
No,
I don't think it is. I don't think it is. All right. I can find out really easily though by just checking our homeworks. Let's see. I can go to
Wait,
assignment.
the
Equation 5A.
15.5 homework is due Wednesday, which is after the test, so
Yeah.
I'd say no.
Yeah. Okay. we're
no,
good
our
then.
test isn't on.
Our test
Our
is
test is on Thursday,
Tuesday.
isn't it?
Oh, it is on Thursday.
You right?
Oh well. If 15.5 happens to be on the test, rest in peace. But I doubt it. All right.
Was the
Let's.
test Tuesday or Thursday?
It's Thursday. It's Thursday. So
Yo, I kept thinking it was Tuesday.
I've been.
That's
Yeah. No. We try and do these earlier.
okay.
There
Let's
was
go.
a time when we would do these the day before. Rest in peace.
I was
Because I'm
actually
doing.
supposed to leave for Las Vegas on Thursday, but then they decided to shut down my national level competition.
What is it for? You might cut out.
Oh, like my national level competition for Ninja Warrior
Oh,
that I've been going up to Tennessee to train for twice a week.
legend. All right. Let's pick one of these green
Oh yeah,
theorems. to do.
Jeffrey's the Ninja Warrior one.
I told
Yeah.
you. When Jeffrey joined I said it's Jeffrey. It's the myth, like the mythical Jeff or something. Or mythical Jeffrey. And then he said, I don't know if I'd say mythical. And then I said, are you sure about that? All right. Green's theorem. Which one of these do we want to do?
None of
You
them.
want to do the one that's circled with the yellow blotch next to it? I feel like that means it's more important.
Sure.
All right, boys. We're looking at a fancy integral sign. What does that mean?
Okay, yeah, 23 is the one where like I don't know what to do because it's not like even
Jeff, take it away.
All right, let's see. Y plus 2x.
You're converting to polar.
No!
Jeffrey.
Oh, hell, do we
No,
actually?
you just do square. No, you just use square coordinates in a circle, which is terrible.
It's 0. Circulation is 0 in a square.
No,
What
because
is-
it's a circle, so it's gotta have circulation.
No! That's so stupid. I don't want there to be circulation.
Wait, does that mean flux equals 0?
When,
No,
when
I
does
don't think
flux
so.
equal 0?
No. Don't make. It's not. The answer's not
Does
0.
flux
Jeffrey.
ever equal 0?
I mean, if there's no force going through a thing, it's 0.
Who knows, man? Who knows? Oh, wait, I gotta keep
Flux
that
is
open.
anything
Hold
that
on.
is force that goes through
Slide over
everything.
here. We're looking at 23 right now. The answer to 23 is negative 16 pi. How we approach or how we arrived at that, beyond me. Let's see. What the heck is
let's
Green's
see.
theorem in the first place? We've been talking
Those are the
about
two
it.
formulas.
Okay, so those are the two formulas. So what does it even ask? It doesn't ask for circulation or flow. It's just
It just says evaluate them, which means find circulation and flux, I think.
but there's
Find them both.
there's one answer for
And it's probably
Add
circulation.
them together.
Nah, I doubt it.
there's
I think
one
it'd just be circulation or Luke.
yeah, negative 16 pi. All right, well then let's hope that circulation equals negative 16 pi then, shall we? All right, how do we go about this? So the circulation formula, we know that from last time. Circulation formula is as follows. So we would do this and it would spit out 2 minus 6 negative 4. All right, good news. A negative sign has appeared. That's good news, and it's a multiple of 16, boys. It's negative 4. It's a multiple of 16. That's what I like to see. We're getting there. All right, 1. All right, checkmate. There's that. Now we have a circle. Don't know what to do with the circle.
Yeah,
I
I
get
get
this
to the
is-
circle and
The
it's like,
circle's for the
Polar
bounds, right?
coordinates.
It's got to be for the bounds, right? It's got to be for the bounds.
yeah,
Polar coordinates.
I refuse
Polar
to do that.
coordinates.
No, I'm not going to do it.
But it gives you 4 pi.
What? That's
not negative
spicy.
16 pi.
Wait, are you telling me that negative 4 times 4 pi gives you the answer?
Yes.
Yeah.
That's if you do it in polar coordinates, bro.
I don't want to do it in polar coordinates. All right. Is there one of these things like how it's a double integral? So what are our two limits then?
Jeffrey, to answer your
It
question,
would be the
though,
top
it's
semicircle
from
and the
0.
bottom semicircle.
But hold on, you can just do it in polar coordinates.
Honestly, polar would be a lot easier because I don't know how to find the
Fine, let's do it in polar.
semicircles.
How do we do it in polar?
You do the
Don't be
OD
like
OD theta, and d
Oh,
theta is 0 to 2 pi, and your radius is 2.
So we get rid of the double integral and it just becomes negative 4 times 4 pi.
Not really, but sure.
That's what needs to happen. Otherwise, it won't be 16 pi. Negative 16 pi. I mean, we've gotten halfway.
Okay. Okay, so what did you get for like the inside of the?
I got negative 4.
You
to
got
start.
you got negative 4, right? So
Yes.
and then let's do RdR theta.
Mhm.
So from d theta is 0 to 2 pi, and r is from what, 0 to 2?
Yeah.
Uh-huh.
Because that's our thing. So
that's
if we
it.
do negative 4 to
0 to 2 pi, that gives you
Two
negative 8 pi, and then
squared.
you do 0 to 2. Yep. It's negative 16 pi. I'm mad that we had to do this in polar, but John was right. But the good news is
simpler in polar.
we did it correctly. We're done.
Yeah, circulation
The
equals
hardest-
Green's theorem equals work equals.
So this all of 15.4 or 15.4 is literally those two formulas in weird ways. Good to know. All right. That's that. Cool. For people at home, I hope you enjoyed that shit show. I'm sure you can tell that we're like less than a month away from the end of the semester. It definitely shows. Absolutely shows.
Quality of the study videos then.
It just goes down. That's what happens. I mean, I can,
Oh, our final exam study video? Oh man.
bro, I can
Are we
barely.
gonna do one of those?
What are we gonna
We
do?
better do one of those.
No, we are. Okay, so that's
final
the thing.
exam?
Yeah, we are gonna do. We have one more video to go, and it's the final. And for the final, I'm going to like make for damn sure that people show up. Like, I want at least like I want people to be there to ask questions.
Wasn't test 3 just you two?
Yeah.
Because I was driving
Yes.
back home from Tennessee, so I couldn't join.
It was just me and him.
It was
We were,
just-
we were just being stupid. We were just being stupid the whole time.
I think test 2
Yeah.
actually had a bunch of people show up, and I think that's
Test
the
1 and test 2 was like the test 1 had the
Yeah, test
most-
1 people showed up, yeah. And then
I
like
mean,
test
the
3
thing-
and
here's
4,
the
it's
thing.
like, I'll pass.
The thing that's like that's a little odd or like is kind of like bad. I'm gonna stop recording because this doesn't need to be there. It's already long enough. The thing that's sort of bad is the fact that I don't need to screen share. I stopped screen sharing, right?
Yep.
Yeah, that's what I thought. When you stop recording, it stops automatically. That's awesome. So
You haven't stopped recording.
did I not? Oh, now
Yeah, it's still recording.